What I'm here to talk to you today about for the next 25 minutes, half an hour, is zero trust to the data center. And so if you want to dive in on this, because obviously the presentation I'm going to give is at this sort of level, and on the stand we can take it right down to whatever level you want. We can talk about what we're doing, the products that sit behind this, but that's an afternoon conversation rather than a half-hour conversation. So we're going to be talking about some of the things that we think are actually the most important elements when you're actually building out a zero trust data center for your environment. I think the thing to start with is, why are we doing this? And the reason that this is happening is because there's a need that everybody wants to protect their data. And we know that. That's really what the core is. Whatever you're doing, it all comes down to either access to data, manipulation of data, sending data around, and that data needs to be protected in the data center. But then what's a data center today? Because that definition itself has changed. The data center could start on the outside. You may be treating your data center as a cloud environment, something that is hosted by somebody else that you're using. Your data center could be your own private cloud, where you've got your own tin, you've got your own devices, but actually you're running workloads on those, so they're still virtual instances. Or you could be running the very traditional version of a data center, where literally you have servers and you have applications running on those servers that people are using. Reality is most of us are probably using all of them in some form, or at least 2 out of the 3 are being used. And that's why it's so important to protect the data, not just so that people can access it, but also for the resilience of the business and to make sure that you don't get into trouble. Because, get to the next slide, the world is constantly changing in how we're doing this. There's massive growth in this, particularly in the last couple of years. We're seeing that it's actually getting that most organizations on both sides, private and public, are using close to 3 cloud types in each. And actually, when we start to talk about public cloud, yes, you may be using 3 different public clouds, but within that, you're probably also using a lot of applications hosted within those clouds that are not yours, without necessarily being aware of what that is. I mean, for example, a lot of our own products, that's a Juniper interface that you're going into, but it's actually hosted in Amazon, because that gives us the scale and the resilience that we need, and it means that our customers can be confident they're always running the latest version, they're getting the updates and things are happening. And then of course private cloud is where you have systems that you want to be able to manage and be in control of. So there is massive growth in that, which has been driven by things over the last couple of years. And it's got to a point where actually the networks have become so complex that trying to consolidate and bring them together is becoming a challenge in itself. It's a challenge that a lot of IT managers, a lot of security and network managers are very concerned about. It's should I be getting on with this right now? Do I need to really get on with this? Or is it never going to be able to happen? But it does need to happen, because if we're focusing on security for the conversation, well, attacks are growing. Attacks are increasing all the time at the moment. We've seen massive growth happening in the last couple of years. To be honest, the 63% statistic here for the number of organizations breached, I haven't seen a lot of change in that. That seems to be a fairly static number. It might go 63, 65, 62 year on year. But the number of attacks that are happening on organizations, particularly when you start thinking about things like, ransomware, to actually stop people getting access to that data in some form, those attacks, once I've got in once as an attacker, I'm probably going to try again and again, because I've found somebody who may be a weak spot for me. So multiple attacks are occurring on organizations within this space. And the organizations that are doing them are getting cleverer too in what they're doing. They're using massive numbers more of 0 days to actually be able to get in where they haven't necessarily been dealt with yet. They're very quick off the mark with these things. And also, if you look at the numbers, the 6.9 billion here that we're saying that they're making out of that, that's an awful lot of reinvestment money, because they're running as businesses too. So what they get, they can reinvest that to make for better attacks next time, which are going to be more successful and keep on growing. So this is going to keep going up. And then within the business, things are changing a lot too. I mean, traditionally, you had 3 groups in any organization. You've got your security team, your networking team, and you've got your application development teams. And they worked in their own little silos. And that really can't be the case anymore. I mean, if you just take one great example that I hear from a lot of people when they talk about just the security team and the network team. The network team is responsible for making sure that your data pipes remain open and clean and fast. The security team perception is the only thing they want to do is close it down and stop people getting out. these conversations need to happen together. They need to be involved earlier. Everyone needs to be involved earlier. Everybody needs to be involved at the right point in that conversation. Security should be involved at the outset in any changes that are happening. People shouldn't be forced into taking on different roles. Application developers trying to consider security and what they're doing because security haven't been involved early enough, that's not their job. That's not what they're experts at, but unfortunately it does happen. We also see that sometimes things are moving so fast that legacy controls get used. So where an organisation is very used to delivering infrastructure type controls of how do we control the network, how do we control policies on the network, they try to deliver those when they're actually creating hosted applications on workloads, and it doesn't work. By bringing these together, any deployment, any security decision will be more successful. And if you look at the stat on the left here, vulnerabilities that are actually discovered during the development cycles of anything that's happening, the average, this is an average that Pwn1 have reported, but the average is about $80 to actually resolve that and fix that. Whereas if you wait till that's rolled out, suddenly that jumps to closer to $8,000. That's a huge pickup, 95 times it says at the top. But of course, there's never just one vulnerability when something's rolled out. You know, vulnerability isn't always a bad thing, it's a weak spot, and if you roll out a new product, the likelihood is there's multiple. So that's multiple of this 8,000 that are going to get rolled out, which 80 would be a lot better to deal with, I think. So when we talk about the zero trust data center, what do we mean exactly by that? So we consider how Forrester talk about the zero trust framework in itself, which if you remember is all about trusting no one. That's really what this comes down to. I will not trust anybody unless I know who they are, what they are, how they've got in, what methods they're doing, and then I'll make a decision on whether I'm going to let them onto my network or into my application. Now the Forrester pillars for this, they actually say the most important components of this are automation and orchestration on the network. Automation is obviously very, very important because there's too much happening for individuals to be able to do everything all of the time. So automating actions on the network and then learning new actions that can be automated is going to make things better. You're going to spot things faster. Changes will always be made accurately. Policies can be delivered immediately as people need them. And orchestration, of course, if you're network terminology, you'll be very familiar with this. Orchestration of the network would be about making sure that people have the most efficient use of the pipe that they've got for the application that they want to deliver or the data that they want to get from A to B, whether that's email that happens as and when you feel like it, or whether it's real-time data that needs to go at a certain time in order to be regulatory compliant or something like that. So orchestration is very important for understanding what you have, where you have it, and what you want to do with it. Then if we move around from there, analytics and visibility. I mean, if I can't see what's out there, how can I ever expect to be able to manage it? I'm not just talking the security angle here either. Obviously, from security, you can't stop what you can't see. But if you don't know how the network's running, if you don't know what's running on it, if you're letting everything go, if you just have kind of default pipes and things that are just running down, you don't know what might be causing a problem. So having that visibility is absolutely essential, and getting analytics from that, which then you can use to drive automation actions, for example, is also very important. And then putting security around network transactions. And by network transactions, we're talking about devices or applications authenticating to the network, or sending data, or transacting with each other, or talking to other people. All of these transactions need to be secured on the network. That's very important. Protecting workloads that you've got out there is one of the benefits out of this. And actually, as I said earlier, because people do have data centers, public cloud and private cloud usage, you need to be able to do that seamlessly across all of those environments. You don't want to have 4 different consoles to log into and 5 different policies to run. You want to be able to do it as simply as possible with minimal changes and minimal space for error. Identity is key. Role-based identity at all levels, knowing everything, and I'll talk more about this later in the deck as well, but knowing who I am, where I am, what I'm using, how I'm getting in, that's all essential for zero trust. Excuse me, protecting data all the time, whether that data is being encrypted at rest on a server, whether it's being transmitted over secure pipes on the network, whether it itself is encrypted in motion, going to the device and then re-encrypted on the device at the other end. Actually, data needs to be protected. At no point should it be exposed that somebody can actually get hold of it and have useful information. And then we also need to recognize the difference of what is making these connections, because traditionally it was us with these things making connections to the network. You know, we were logging into our laptops or our desktops or whatever we were using, and now it isn't. Now it could be anything that's connecting. It could be a light bulb that's making a connection. That camera could be connected on Wi-Fi back to the network. Any of these are devices that can connect that don't necessarily need to have a human interaction. So when you start talking about light bulbs, how do you know that somebody hasn't decided to plug in a rogue light bulb that's actually trying to collect information off the network? You need to be able to track that. So if we take this a real 10,000 foot view, and I promise this is the most 10,000 foot view I can give. Sultan over there can take it down to a 2 foot view, can't you? He's like, cool. I nearly said something there on the microphone. He's like, thanks for that. But anyway, so the 10,000 foot view of how we do this is, on the one side, you've got the private cloud environments that you need to protect. On the other side, you've got your public, all underpinned by identity. Identity is absolutely key in anything that we do here. Identity of the device, identity of the user, identity of the workload. If you don't have that information, then you really can't hope to successfully protect your environment. But that kind of gives you the view. All of that is then wrapped around, like I said, with visibility to know what's happening, to report information, to give you analytics that can then drive your automation actions and can also drive orchestration by being able to make recommendations of maybe capacity changes that need to be made, or rerouting, or updates that need to happen on the network. Excuse me for clearing my throat. I've got a terrible cold today, and I don't think I've got a mute button, have I? So what I'm going to do now is actually take you through what we believe are the 10 key elements when you're looking at doing a zero trust data center in your environment. So number 10, visibility. Visibility into the invisible, which I talked about. If you don't know it's there, how are you going to do anything with it? I'm assuming at some point most of us have at least done driving lessons here. And one of the key things that somebody tells you as a driving instructor is your blind spots, the things you can't see. When they do that, they will say to you, okay, well, there's ways around that. So, you can look over your shoulder. That's something that you can do in a car, to actually see in the blind spots of the B and C pillars in the car of what might be coming. That's what we have to think about when we're doing anything on the network as well. There are going to be blind spots. There's places where you may not be able to see. So how can you actually look over your shoulder to get some kind of a view into what's going on? You need to firstly know what those blind spots are, and then secondly, think about methods that enable you to be able to see into them. Maybe if it's on the network, then what you're thinking about is, okay, is there usage information that I can see, ups and downs on the network, or how are people actually getting at that data, and is there something that's not happening there that's unusual that I wouldn't normally see? I could use analysis to actually look at behavioral patterns of access. So if I'm suddenly seeing people coming in or devices connecting at times that are unusual, is there something happening there that I wouldn't expect? And there are genuinely some really good, they're very interesting stories of breaches that have occurred in the past where actually the bad guys have used downtime to be able to exfiltrate data from a network because the teams didn't see that. They didn't recognize that as a blind spot. So when everybody was out, data would disappear off the network through devices, and then it was stolen. So understanding what your blind spots are is very, very important in order to be able to start managing effectively. Segmentation, which we've talked about a little bit. So we're all familiar with network segmentation. We've done it for years. I talked a tiny bit earlier on it. At the very most basic level, we used to think about network prioritization for the traffic that was going out because we were dealing with smaller pipes. And so you had to say, okay, well, email is a fire and forget. It gets there when it gets there, so that's the lowest priority. But actually, if I'm dealing with website, well, that's slightly higher priority, but again, it's not something that's absolutely urgent. But then at the level of where maybe I'm in a manufacturing organization and I'm making things, now I'm down to the millisecond levels, and that has to be real time, so it gets high level priority in a big part of the pipe. So we used to segment for that. And then even at the switching level, where we segment for different offices and things, well, we need to take this to the different next level for zero trust. We have to segment on everything that we can segment. So users, devices, locations, clouds, all of these things should be segmented in order that we're going to be able to successfully manage the network to be able to establish the correct level of trust that's going to allow a user to get access to the resources that they want to be able to access in a seamless manner. And it's a word I'll keep using, is that is really, really important. One of the biggest pain points that a lot of people report when they're talking about moving to a zero trust environment is actually the impact on the user of going there. There is a change to people who are using this. Devices, fine, once they're in. But as a user, there will be a change. The likelihood is you're going to have a certificate to authenticate through. You might have another level of authentication that may be a biometric or something like that. And users, when you introduce things to them, if they're difficult, they try to circumvent them, don't they? They're like, I don't like that, I'm going to find another way of doing that. And that's how shadow IT was invented, which is what we really don't want to occur. So it is essential that you have seamless policies, everything should follow the users, everything should happen automatically, and it should be the same experience for somebody wherever they are at any point. Whether they're accessing resources on applications on your servers, whether they're actually going out to the cloud, it should be the same for everything. Then of course the other thing is, because you've segmented down, now you can actually start to protect individual applications, which is why we talk about workloads to microservices in the middle box here. There's more and more common these days that applications don't get written as big blob applications anymore. They're actually developed as microservices, which makes them a lot easier to upgrade and add new features, but you need to protect each of those services so that they're themselves not at risk. Our own Mist environment is entirely based on microservices, just a little advert in the middle there. Identity, we talked about identity as being key, but what do we mean by identity? Because identity used to be my logon credential, and that was it. That was all that mattered. Add a password, job done. That's not the same anymore. Identity now, for me as an individual, is who, where, and what. That's me as a Juniper employee. Then you can correlate that with the devices that I have. So my laptop is something else that helps to identify me. That's great, but then we have to consider, well, maybe it's not my laptop and maybe there's no who, because we're talking about an IoT device. So in that case, it's what and who and where, because it's what's the device, who owns it, and where is it? What is the type of device that we're talking about? How does it connect to the network is another thing as well. I don't know if anybody looked at this, but during the pandemic, some organizations took the opportunity to actually go and scan their offices for vulnerabilities because the office was empty. And so there was a chance to say, well, there's no users in there, what else is happening? Bluetooth is a very commonly used attack vector that was very commonly left open on a lot of devices, things like video conferencing televisions and telephone boxes and things like that. They have Bluetooth on them. Well, that was a method of getting in. And so, how are these devices connecting? Is it a safe connection? Is it a secure connection? What data are they transmitting? And how are they transmitting that data? So what's the expected behavior of this device during a day? Where is it? And of course, really importantly, actual accurate location of that device. So the reason we call out location separately on here, location because it could just be an entry in an asset management database. It's in floor 3 of the office. But what about when you get down to the level of this is a connected device? So on a wire, yeah, I know where it is. It's plugged into port E23. If it's on Wi-Fi, then I can bring it down much more accurately. On Wi-Fi, if it's on Bluetooth, I can use BLE to actually bring it down within feet. So location is a really, really important component of this. If a device suddenly pops up in the wrong place, or if the wrong device suddenly exists where there shouldn't be a device. And taking this to the edge is very important as well. So when we talk about identity and when we talk about really the tenet of zero trust being that you trust no one, actually securing right to the edge is very, very important, and the technologies that enable you to do that. So firewall as a service, so that instead of just relying on central firewalls in the data center, you actually can have firewalls deployed right to the edge of the network that will leverage exactly the same policies relevant for the location that they're actually based in. You can have web gateways, so that people actually, when they're coming into the network, they're proxied. We know what they're accessing and we know what they're doing. Of course, we have zero trust for authentication we've been talking about. And at the top, which I didn't mention, CASB and DLP. So being able to control access to applications and being able to protect the data that people are using, categorizing information on the network so that you know if something's being moved that shouldn't be being moved or it's being taken out. This slide, by the way, is Juniper's most recent announcement, is actually the addition of CASB and DLP into our solution, which gives us a full stack SASE solution, as well as enabling the last part of our zero trust story, which we've been working towards for the last year. Number 7, seamless policies. I've talked about this one quite a lot, but this is such an essential. And it's two ways for this. Users and devices need seamless policies so that wherever they are, the experience is the same. They don't want to go and log into a different office and find out it's very slightly different, except in the way of the physical environment that they're actually located in. On the other side, the administrators, they don't want to have to set up 5 different policies that basically do the same thing for different locations. What they want is one header policy that flows down to everything and doesn't require changing. Why is that? Because if they've got 5, there's more chance that at some point a mistake's going to get made in one of those policies. There's a button's going to get ticked, a button's not going to get ticked, and it's going to cause a problem down the line. So having one policy to do this is essential, whether you're managing a workload on a piece of tin, whether you're managing a workload in the cloud, whether you're managing a workload in your own cloud. The policy that manages that, it should be identical. There's no reason it shouldn't be. And so that's something you should be looking for in a zero trust environment. Understanding how your network's actually working is also very important. Again, talked about a little bit about this with segmentation and things, but knowing what's going in and out of the network is essential if you're going to know when things are going wrong, and you're going to get an early header to that. Understanding where traffic's going to and where it's coming from. Now, what's the catch here? Well, the catch is it's mostly encrypted, isn't it? Everything is transmitted in some form of an encrypted packet these days. There's very little that comes across as clear text without making it into the Daily Mail these days. So we have to think about how can we look at that? And there are solutions that can do this. The most common one is to have a man in the middle that does that. It's not ideal because there's a hit on the network from doing that. But there are also, and we do have a solution which allows you to do that in line. Why do you need to decrypt encrypted traffic to be able to spot whether it's something you might not want to have? Actually, we know what things look like. We have so much information out there. There's so much data out in the world that tells us what are bad networks. So what would a bad source be for that information to come from? What do packet makeups look like for encrypted packets when I should be worried about them? The validity of the certificates that are being used to transmit that information into my network. All of these are key pieces of information which actually can be used to say, I don't like that. I'm going to let you know I'm not happy with that, and you need to do some more analysis or reject it. And that's something that we can actually do in line. So there's no impact on the network performance. Everything still carries on through, but you're being alerted without the need to decrypt that information that something bad may be trying to get onto the network. So no impact on performance, no impact on privacy, and you're still getting the information that you need. Automation, which we talked about, you need to automate absolutely everywhere that you can. There's no way that we're going to be able to keep on keeping up unless we're looking at automation tools. And automation doesn't have to be the whole big scary framework. Automation could be as simple as I said, having policies which get applied automatically to the devices based on read configuration out of those. So by looking at the meta in something that's the metadata of something that's coming into the network, I can extract information that allows me to automatically apply or recommend a policy. That's a level of automation. But then moving forward, we will see more and more automation of security actions, automation of things moving around on the network, automation of alerting or changes that need to be made. So automate absolutely wherever possible. Extend what you have, number 4, extending what you have to make it, did I say something then? To make it so that hopefully everything becomes a part of the overall security story. This is actually something that you're seeing more and more vendors are starting to talk about. We've been talking about this for a long time. Just think about it. I mean, if you've got a router on the network, that router is responsible for passing traffic outside to inside. It's a very powerful piece of equipment. Why would you not make it part of the security story? It knows where things have come from. It knows it can know about bad IP ranges out on the network. It can know about bad packets. So by making routers and switches and access points part of your security framework, then A, you spot things faster, B, you can reject things before they actually get into the network, And C, you cut down the work the firewall's got to do. So your firewall can deal with advanced things. It doesn't have to deal with the basics, like, ransomware, data attacks trying to come into the network. So where people are trying to transmit information in that they shouldn't, that can be rejected at source. So make everything a part of the security infrastructure, monitor it all of the time. That will make everything more effective. Become effective at blocking the basics. Now, you might think this is an advertising slide for where we've done well. It isn't, although we have. What it actually is anytime you're looking for a solution, don't read the Amazon reviews for it, because the Amazon reviews are all the people who actually went and bought it. Go and have a look at some independent reviews for products, and these are some of the best. I mean, NetSec Open is I don't know if anybody's looked at it. It's a real up-and-comer. They absolutely do not pull punches when they're doing the reviews on the products that they're looking at, and they also insist on doing the testing. Very expensive to do the testing with them because they will do the whole thing. But go and have a look at these sites, look at the products that you want to look at, and see how the vendors have rated as a vendor. And then that's your great start. Then you can start to get happy and you can narrow down from there. Yeah, I mean, if you want to take a picture of those, it is worth having a look. But there's some really, really good sites. Like I say, NetSec is my current favorite for looking at on here if you want a recommendation. But then based on that, you can then validate your requirements against the specific effectiveness of the products that have been reviewed on these sites by open people. There's no sponsorship, there's no paid reviews. These are people who are doing this because they want to get the right message out into the market. Application uptime also is essential. Understanding how your applications are performing at all times so that you're able to spot if something's going out of whack in some way. Availability is obviously absolutely key for your users, because if something goes wrong, there's going to be a problem. Having a plan for if that happens, having a plan for enough an upgrade goes wrong, but also actually having tools that monitor that availability on the network so that you're tracking how the network's performing. And then number one, quite simply, don't stop because you get stuck. There's too often we are perfectionists in this industry, and we hate it if something doesn't quite work the way that we wanted it to, or we get to a point where we can't quite move forward. This is where the 80-20 rule kicks in. Don't let perfect be the enemy of good. The chances are other things will pick themselves up. It is essential to keep moving forward if you're actually rolling out zero trust networking, if you're rolling out a SASE environment, keep moving forward to get to where you want to be. If there's a problem, come back to it later, deal with it, unless it's an absolute showstopper, obviously. And then some prime places where you might want to think about using zero trust in your data center. So at the gateway, being able to control who has access to what in the way of corporate resources and what they're able to do. In your, in your interconnects, being able to control the data flow on the interconnects whilst making sure that people actually still have access and optimizing the flows as the network needs to scale up and down on its own. Intra-data center connections. So if something does go wrong, if you've actually got zero trust in your environment, then you could very easily limit the impact of that attack, because you can very quickly segment out parts of the data center so the bit that's been impacted goes offline, the rest continues running, and hopefully people are less affected. Leveraging the public cloud with this. I'll talk more slowly then. I've got 5 minutes. Leveraging the public cloud in what you're doing with zero trust as well, because the benefits of public cloud are innumerable. Because the key ones are resilience, reliability, the fact you always know that you're going to be running the latest version of a product. Everything's on demand. So public cloud is great, but it does need to be well secured. There's too many stories out there of environments that weren't secured successfully enough. Zero trust can really help with that, as well as empowering your business to be successful. And then at the specific workload level as well, you want to be able to effectively protect mission critical workloads and applications. And actually, when I think about it, there should be another piece on here as well, which is you need to understand what they are before you start. There is a big tendency in security that we go in and say, okay, I've got security, I'm going to do it everywhere. The reality is you probably don't need to do it everywhere. You need to understand the value of the applications and the resources that you're running, how important they are to the business, what the real-time value of those is if they disappear, and then you protect those. There's generally no need to have the same level of protection applied to everything. It's expensive and it's hideously difficult to troubleshoot. And an example of that would be, why would you want to protect a publicly accessible PDF on a web server that sits in the DMZ of your environment anyway, when actually you want everybody to get hold of it? You'd be better off to have a failover solution, so if something goes wrong, it just gets rewritten. What you want to put the money in is protecting your secrets. Okay, so that brings me to the end.